In the last couple of videos, we looked at the options available in the table menu for merging tables and changing the table metadata and so on, as well as the options available in the bottom of the data menu for editing data series metadata, etc. And in the next few videos, we will look at the options available at the top of the data menu for transforming your data in different ways. In this video, we look at the perform function and smooth data options. So here I have some cyclic voltammograms, and perhaps I want to change the potential to be against another reference electrode. In this case, the potential is versus silver-silver chloride, and maybe I want it against standard hydrogen electrode. So I need to add a value of 0.197 volts. That's the potential of the silver-silver chloride electrode with respect to the standard hydrogen electrode. To do this, I can select the potential data series and choose perform function. Here we can see that the function is add value, and we can choose the data, namely the table and the data series. This is already selected, and then a constant. The data series is called A and the constant is called C, and we can see that the output will be A plus C. So for the constant C, we just need to choose 0.197 volts. And in this case, the potential is already with the unit volts, so we could also just put in the number, and then this will be assumed to be in the same unit as the data series. Also, another option would be to type it in another unit, like 197 millivolts, and then this would be converted to the unit of the data series. At the bottom, we can also choose where the output should be placed. So maybe I want to replace the data series and not keep this old potential data series. I choose OK, and then we get this new data series where this value has been added. So this potential is now with respect to the standard hydrogen electrode. And I want to do this for all of my CVs. Luckily, I don't have to go and do this for all of the tables manually, but I can just select the rest of the tables, and then I do the same thing. So select the data series. Maybe I can just put in 0.197 in this case, choose replace A, OK, and then it will ask me if I want to repeat this for all of the tables that I selected. So I choose yes, and now all of the CVs have been corrected for the new reference electrode. Another thing that we might want to do is to normalize the current to get the current density instead. So here we should divide by the area of the electrode. And I do it the same way. I select the current data series. Now I will select all of the tables, so I just have to do it once. Click perform function, and now instead of adding a value, we need to divide with a value. So here in the list we have a lot of different functions available. In this case we should divide by a value. We can see that the output will be A divided by C in this case. So we need to put the area of the electrode as the constant. In this case the area was 0.29 square centimeters. And maybe in this case I want to not replace the data series but add another one, which is the normalized current. Press OK, and then again it will ask me if I want to repeat it for all the tables. I choose yes, and now all of them will have this normalized current. So as you saw, there are a lot of different functions available, and by using the what's this button and clicking perform function again, we can see the help pages for this option, and scrolling down, all of the functions available are listed. So we have simple maths, exponentiation, differentiation, integration, logarithms, Fourier transform, normalization, and also some options for smoothing, etc. And finally, I just want to say a couple of words about smoothing, because yes, in the perform function, we do have in this list the options to choose different smoothing algorithms, but there is also another option that gives you a little bit more flexibility in smoothing your data. In fact, these CVs are already not very noisy, but I can load some other data that has some more noise, like this OCP measurement. Here the potential is rather noisy, and what I could do then is go to data, smooth data, and here we have some more options for choosing the parameters for the smoothing. We have the same algorithms available, and we can choose the data as usual, as well as where the output should be placed. And the degree and the lambda value for the Whittaker-Henderson smoother gives you some more flexibility in how to smooth the data. If I choose the default values, we can see that it has removed quite a bit of noise, but it's still not very smooth. If I again smooth data and choose a more aggressive lambda value, now it's a lot more smooth. So if I just plot those to compare the difference, this is the original data, and here with the default settings, quite a lot smoother, and then we can get it even more smooth with choosing a different lambda parameter.